Hey guys, good afternoon. Please put your cell phones away. And what we're going to do is we're going to start off with these two problems. And then we're going to work on the worksheet from Monday. What we're going to do is part 2. So if you do have this, just take this out. And a separate sheet of paper so you write all work on and maybe some notes on this. There's going to be a lot of opportunities for extra credit today. And we're going to be working with the calculators. We're really going to bring home the idea of inverse functions and composition functions. Again, there'll be a lot of opportunities for extra credit. Next week, we're going to move on to logarithms. We'll finish out the year with that and a little bit of trigonometry. So as I take attendance, I want you guys to work on these two problems, and then I'll check them as I hand you guys calculators. Yes, I do. You want to use it? Yeah. Alright, so those of you that just got here, please take this out. We're going to do part 2 today. We did part 2 on Monday with the substitute. We're going to do part 2. And if we get through this, we'll have time to go through some of the extra credit together. Yeah. You need to copy this. If you lost it, that's fine. I have plenty of copies. You got this? Monday? If you find it, just leave it. All right, and please take out your headphones. We are on the home stretch. Here's almost over.
Almost. It'll be we're going to switch X and Y, so they're like Y is up there and switch them. So
Is it this one?
Yeah, you got it?
Yeah. Wait, what is it?
Dakota.
No.
I only have one person turned it in for Monday.
Are you sure?
Yeah.
I finished. I just checked
I could look for a little more in depth, but
I'm not that fine about it, so don't worry about it.
Bless you. Tristan, Xavier, Emily, Cody. Amanda's here.
Oh, it's right here.
Yes. Shamna. Danny, welcome back. All right, you guys should be finishing up this bell work right now. We're already 5 minutes into class. So, Amada, what does an inverse mean? What is the textbook definition of inverse? Remember what an inverse is? That's all right. Karen, can you help her out? Opposite or reverse, right? So if I'm going to find the opposite or reverse of this function, what would I do? So I'm going to come around and check and hand you guys calculators. We're going to be using graphic calculators today. You guys want to use the bottom of this sheet? That's fine.
They like died. Oh, yeah. I want to, but I don't know. What's it been like? Both times?
You guys remember this is participation points here. I want to find the inverse. The concept behind inverse is that it's the reverse or the opposite. So if I had an ordered pair, like 3, 1, the inverse of that ordered pair would be the reverse, 1, 3. So what are we doing here with inverses? This is also, you haven't turned this in. It's basically how we're doing the homework assignment with inverses. Make sure you get that in if you haven't. Flipping x and y. So if I look at this function, f of x, f of x equals x squared, there's 3 steps here to finding the inverse. First I'm going to say y equals x squared. I'm writing this as an equation. Alright, you guys should be writing this down. Do not mess with the calculators yet. We will get to those. We'll be using those most of the class period. And now I want to take the reverse of this. Just like up here I said 3, 1, the inverse is 1, 3. So the inverse of y equals x squared would be x equals y squared. That's the entire premise here. And the final step is to solve for y. And how do I do that? Henley, how would I solve for y here if I have x equals y squared? How do I get rid of that exponent? Take the square root, yeah. If it was 2y, we divide by 2. But if this is an exponent here, we just take the square root. So the square root of x equals y. And that's the inverse. And that'll guide you through the homework assignment if you have not completed that. The inverse would be f of negative 1 x equals the square root of x. That would be the inverse. Again, we're moving on from this next week. And we'll still be building off it, so you just need to know how to do this. I will be after school on Monday if you need help with this stuff or the other assignments that coincide with this. So now number 2, composition of functions. Inverse and then the composition. I want to figure out what is the f function at g of x. Remember, like the movie title, Inside Out? That's how we work these problems. So I'm going to start with what is g of x? X plus 1. So what we're really finding here is what is f? The dying marker. F of x plus 1. Because this is really what g of x is. So now my input is x plus 1, so I'm going to go over to this function. The f function is just x squared, so all that the answer would be f of x plus 1, f of g of x equals x plus 1 in parentheses squared. integrate final exam review into everything we do from here on out. There's only a couple weeks left before the final. So this would be an example of 2 questions on the final that are kind of intertwined. And the final step would be to factor this. And if I x plus 1 squared, we're going to use the FOIL method, because this doesn't turn into x squared plus 1 squared. It's really x plus 1 times x plus 1. Then use the FOIL method, or a 2 by 2 table. First terms for f, x squared, just multiplying. And x, outer terms, x times 1, x times 1 for the inner terms. And then the last term, 1 times 1 would be 1. So this would turn out to be f of g of x equals x squared plus 2x plus 1. All right, so once you guys have that copied down, turn to part 2. The assignment we started on Monday. Does everyone have that in front of them? You guys got part 2? All right. So like I said, there's a bunch of opportunities for extra credit today. One of them is taking this imaginary example problem and applying it to real world situations. So we read part 1 here. Or excuse me, part 2. Does everyone have that in front of them? We got the population of a country is initially 2 million people and is increasing at 4% per year. The country's annual food supply is initially adequate for 4 million people and is increasing at a constant rate adequate for additional 0.5 million people per year. Can this be related to the world today? Yes, it definitely can. Why do you say yes? How can this relate to real world situations? Danny, what do you think? Haven't heard from you in a while. How can you relate this problem to situations that are in the real world situations in the world today? What is this problem really about?
About how much food they make a year for a
Versus,
certain amount of people,
yeah,
and then at the same time how much people are born each year. How
Yeah,
much
like-
population's added again.
yeah. Couldn't that be applied to the world today? Population of the world is increasing rapidly, but is there any more space for farming? We just go to the moon and start farming corn, maybe? Probably not, right? This could be a real world situation, maybe in your lifetime, maybe in my lifetime. Food supply versus how many people there are on this planet. But there's lots of other factors that affect hunger and starvation. Like, there are people starving right now, but that's not because there's not enough food, right? It's because of economic reasons and greed. What other ways besides food can this be applied to the world? What other resources do we need to survive? Darian, what do we need to survive? What's 97 or 96% of our body made up of? Water, right? What's going on in California right now? Droughts. We need fresh water, right? Not salt water. That's going to be a problem in my lifetime for sure. Like if I was walking down the street, going to Basha's, going to the grocery store, and I found a suitcase with $10,000 in it. I'm dreaming here, but I would invest that in water as a commodity. It's going to be a commodity soon. Do you guys know how Kayanta's doing with water? What kind of water supply you guys have for the reservation?
Aquifer. No.
that should be a concern, right? Do you ever think about that? Where does all the water come from? Do you guys know there's reservoirs on the res?
Yeah.
They're deep underground and they're plenty full of water. You guys are doing all right. And a while ago, scientists were telling California as a state, you guys need to start building reservoirs, conserving water. I don't know if Arnold was the governor at the time, but he was like, no, we don't need to do that. We've got enough water. Get to the chopper and get out of here. And now, I was like, oh my God, what have I done? I'm so thirsty, help me. But that's going to be a worldwide problem very soon, unless you want to invent something that can turn salt water into fresh water economically. So these are great ways to do extra credit. You guys will be turning this in at the end of class, but if you want to go on the computer and answer some of these questions on part 2, but using real world numbers. How fast is the population increasing? What rate? What is the water supply at? When are we going to run on water? When are we going to run out of food? Those would be full assignment extra credit ones. And there's going to be something else we're going to do next, which will be also extra credit, for which you guys have to bring your grades up. But anyways, let's get to what's not extra credit, our activity today. So, number 1 is the population or the food supply growing at exponential rate. Which one is growing exponentially? Christina, which one do you think is growing exponentially? You got a 50-50 shot if you don't know. Which one exponential rate? Gabriel, you want to help her out?
Population.
Population. Population is growing exponentially. Why do you say that?
It's not at a steady rate.
It's not at a steady rate. What makes you think that from the question? It's so blurry. Is there a phrase or anything in here that you're like, okay, this is growing exponentially?
4% per year.
Yes, good job. This should be something we underline. Population is growing 4% per year. That means after 1 year, it'll be 2 million plus 4%. And then after 2 years, it's going to be 2 million plus 4% from the first year, and then 4% of that too. But the food supply is not growing exponentially. How fast is the food supply growing? Artasia, how fast is the food supply growing?
I don't have my paper. Say the question again.
Flip it over. Here, I'll help you out. The country's annual food supply is initially adequate for 4 million people, and it is increasing at a constant rate. Adequate for an additional 0.5 million people per year. So we've got exponential. What kind of graph is that going to look like? Is it going to be a straight line?
Yeah.
The exponential?
No.
No, it's going to be curved. But our food supply is growing at a constant rate, which means it's going to be a straight line. So linear growth here, we're going to say this is our food. Exponential growth, that is our population. So I'm going to say the linear growth here, we're still going to call this f of x. Now I have to fill in what the slope is and the y-intercept. Try to come up with a function for the food. What is that going to be? What is our slope? Tristan, what do you think? So we're looking at the food, linear growth. Got to start with a slope. Constant rate, 0.5 million people per year. Well, the food supply is in terms of population. Our slope is going to be 0.5 million per year. So x represents years. We're really figuring out f of x. We're going to say 0.5 x plus something. How much food are we starting out with? Initially there's 2 million people and food for 4 million people. So our first equation is 0.5x plus 4. Remember, this is our starting point. 2 million people for population and food supply for 4 million people. So what does x represent then? What are we inputting every time into this equation or function? What am I going to input? My output is going to tell me how many people per what? Per, it's all over the problem. The very last word, per year. So what we're inputting is years. Your years go right there. And then that means input, so we put that there. We're outputting number of people. How much food, how many people can we feed? That's what the output is. And our exponential function, a is our y-intercept, which for population we're starting with 2 million people. And I'm going to say p of t. So p of x. P of x equals, so p is for population, this function is for population, this one's for food. 2 times 1 plus, what is my rate of increase? 4%. 4% is a decimal and is 0.04. So 1 plus 0.04 to the x power. And we just answered number 2. What functions for population and growth food supply? Those are right there. Just show an arrow. Now here's where we start getting the stuff that's going to be important to our lives if we apply this to real numbers about our population and food supply and water supply, possibly natural resources. When is solar energy or green sources of energy going to be important? When are we going to run out of oil? Or you could, if you're into jewelry, you could say, when are we going to run out of diamonds? How many diamonds are mined every year? Anything that you can apply this to a real world situation can be extra credit. But for our imaginary country here, number 3 says, in approximately what year will this country first experience shortage of food? This is going to become a systems of equations problem. Because if I rewrite these on the bottom here as equations instead of functions, y equals 0.5 x plus 4. And then remember, x is time in years. Oops. Talking about time in years, and y represents, what does y represent? What are we outputting again?
Population.
Population. Number of people. Because even in this function here, food is in terms of it's going to output how many people can we feed. And in this function, it's how many people are there. So if I have my food function of number of people, and then I've got the function of the actual population, 2, and I'm just going to write this as 1.04. X power. And I want to find out when are we going to be short? When are we not going to have enough food? First, I want to figure out when are we going to have exactly the same amount of food. And to do that, I want to figure out where these two lines would intersect. Where this curve and the line would intersect. Because then they'd have the same value for x and y. At a certain amount of years, there's going to be exactly the same amount of people as there are number of people versus how many people can be fed. Remember with systems of equation, this is review for the final. I would say solve for the variables, right? And then plug that into the other equation. So 0.5x plus 4 equals 2 times 1.04 to the x power. But we're going to run into a problem here. We're going to need our calculators from here on out because we cannot solve for x yet. Just like the problem I gave you before the NEWA testing. 2 to the x power equals 7. We can't solve that yet. A variable is the exponent. We need logarithms to solve that. So what we're going to do is we're going to go to the the calculators, and they're going to find that intersection point for us. Yeah. So first of all, I left out the year. We're going to write this is in 2016. This is this year. Starting off this year. And so we can't solve this. We have x, our variables in the exponent. So I want you guys to take out those calculators and turn them on and press y equals. And I'm going to turn one of the lights off so you can see my calculator screen. And it's important that you guys follow along closely. They're already in there?
Yeah.
All right, you're ahead of the game then. And try not to drop these calculators. I just did. All right. So can everyone see that screen? It'll get there. So the first thing I want you to do, just like when we were working on the calculators before, we got to enter in these functions. So we'll press y equals at the top. And y1 is going to be our food supply. No, that's wrong. That's why that wasn't working for whoever was using that. So I want to enter this in exactly. 0.5x plus 4. I'm starting with 0.5. Remember, our variable is right here, next to the alpha button. 0.5x plus 4. And then press enter. So please stay focused and follow along. And just wave at me if there's something wrong with your calculator. And I'll try to go slowly through these instructions. And then the next one, I want to enter this in exactly as I see it too. So I'm going to say 2, and then in parentheses, 1 plus 0.04 parentheses. And then if I want to say to the x power, everyone got this far? Above the division sign, this means my next number is going to be an exponent. So I press that. And I'm going to write x again next to the alpha button. And then press enter. You should have this in our calculators. Got it? You good? All right, if you want to, you already got this in, you can press graph. See what happens. Yeah. No, that should be it too. Yeah, press the graph button. Yeah. So the graph button right here, we're going to press that.
Wait, what is that? Just like a review.